Hey everyone, welcome to your Play Posit for the week. We will be wrapping up Unit 2. So I just wanted to do a few more practice problems where we are factoring. So it says to find the factors and the solutions to the following quadratic. First, remember, we're going to look and see if we're able to factor anything out of all three terms. And it looks like they all share a factor of 2. So first, we will take out a factor of 2 from each of these terms, which means we're going to divide each of them by 2. So this first term we have left is n squared plus 3n minus 6. Okay, now we're going to look to see if we can factor what is left. So it makes the inside polynomial so much easier to work with, right? We have much smaller numbers, and we're going to see if we can factor it. So I am personally going to make my mod chart and do the first times the last. That's negative 6n squared and the middle term. And remember, we're looking for two numbers that multiply to give us this number and add to give us this number. So let's see. 6 is negative 6 times 1, negative 1 times 6, and then negative 2 times 3, and negative 3 times 2. So it looks like none of these add up to give us positive 3. So we can't go any further. So let's look at this in the Desmos. I want to see what it tells us. And remember, we're going to use x's. I'm just going to put the original polynomial. You could put the factored form that you already have with the 2 on the outside, plus 6x minus 12. All right, so it definitely has some factors. But we haven't yet learned how to factor something of this nature. We will be looking at the quadratic formula soon. So this is really where we have to stop with this one. Let's look at the next example. You can see we have 3 terms, but we only have one term with a variable. So let's combine like terms. We'll subtract 55 from both sides, and that's 64. And there's kind of 2 ways to do this. We could do this the difference of 2 squares, or it's funny, we could actually put the 9 over there. We could have x squared equals 64, right? And then we could take the square root of both sides, and you get x equals plus or minus 8. Let's put this in the calculator and see. X squared minus 9 equals 50. Here it is, negative 8 and 8 are our solutions, or our zeros. All right, let's find the factors and the solutions. Oh, one thing here, find the factors. So that's something we should talk about. This can be written as x plus 8 and x minus 8 equals 0, right? And then you would solve each of these for x, and you get x is negative 8 and x is 8. It's another way to do it. These are known as the factors because they're two things being multiplied together to give us the original polynomial. We're used to factors as being numbers, like the factors of 8 are 2 and 4. But definition of factors just says it's two things being multiplied together to give us what we're given. So here, we have two big factors being multiplied together to give us the original polynomial. So those are the factors, and then these are the solutions, negative 8 and 8. All right, let's get everything on the same side. So we'll do minus 20 and plus 7y. And now let's see if we can factor. Can we factor out a GCF? Ooh, unfortunately, we cannot, right? Because 7 is prime. So we're going to go straight to the Ma chart. And we'll put negative 60, whoops, negative 60 y squared here and 7y here. And let's start listing the factors of 60. So we have negative 60 and 1, negative 2 and 30. What else? Negative 3 and 20. This is where I just start going through them systematically. Like, does 4 go into 60? And look, you can use your calculator. It does. 4 times 15 is 60. 5 goes into 60? It does. By 12. This is a big one. And of course, 6 goes into 60. So are there two numbers? And remember, we can switch the negative on any of these. And sure enough, here it is. Negative 5 plus 12 is 7. So we found our two numbers to replace the middle term. Minus 5y plus 12y minus 20. And we will factor by grouping. So the GCF of the first two is a y. We have left 3y minus 5. And the GCF of the second two is what? 4? Yeah, you could take 4 out of both of these. So 4, so we're left with 3y minus 5. Yay, they match. So our final answer is y plus 4 and then 3y minus 5. These are the factors. Y plus 4 is a factor. 3y minus 5 is a factor. And then we can set them each equal to 0 to solve for the solutions or the roots. So y is negative 4 and y is 5/3. It's so funny to see y because it's really x, right? But it's just whatever variable they give you. So they sometimes give you z or t or b. I don't love the fact that we use y here because that could be a little confusing because the solutions are the x values. We can always plug this into Desmos and you would see that it crosses the line, the x-axis at those two values. Okay, we have a quadratic. I'm going to get everything on the same side in order here. And we'll do our Ma chart, right? Because there's nothing we could take out of all of them. So we have 42y. Oh, wait. Yeah, that's a squared. And negative 2 in the middle. 42y. So we have 1 and 42, 2 and 22. I don't think 3 works. Well, let's just see. Oh, it does? Weird. Okay, 3 times 14. I never would have remembered that. How about 4? Nope. 5 doesn't work. 6 works because it's 6 and 7. Let's graph this one and look at it. Okay, let's see. Squared. Remember, we have to use x's because that's what the calculator likes. Minus 2x plus 7. All right, let's zoom out. Oops, out. Okay. So you can look and see that this is not touching the x-axis at all. So the first note here was that there were no two numbers to give us negative 2. So we couldn't factor it. by hand yet. And then when you look at the graph, it never crosses the x-axis. So we would say there are no solutions. No solutions. Doesn't cross the x-axis. All right, let's try some actual not actual problems, but some sort of SOL type questions. Select the correct answers. When factored completely, identify the factors of this polynomial. So we're looking for all the things that multiply together to give us this polynomial. So you could certainly guess and check and take these and multiply them out, but let's just factor it. So it looks like we can take a 3 out of everything. So we're going to have 3x squared minus 13x minus 10. That helps. And now we can factor. So we'll do 3x squared times negative 10 and then negative 13. And already you can probably see if we do, well, maybe not. Okay, let's see. We want a negative 30. So that's negative 30 and 1. Or negative 15 and 2. There's our negative 13. Negative 15 plus 2 is negative 13. So we will split the middle term. And see what we get. We're going to group the first two and group the second two. So we have this 3 hanging out here. I'll keep it out there all the way till the end. So we're going to take out a 3x from each of these, and you have left x minus 5. And we'll take a 2 out, and we have x minus 5. Yay! So we have 3, and then 3x plus 2, and then x minus 5. There we go. So we would click all the ones. We would click 3, 3x plus 2, and x minus 5. And if you were to multiply all of those out, you would get right back to that original polynomial. What are the solutions to this equation? So here we're using brackets to show solutions. So each of these have 2 solutions. And you really have a choice. We have a few ways to find solutions. We can find them by factoring. We can also find them by graphing. So in this example, I'm going to graph it. 2x squared plus 5x plus 3. 2x squared, plus 5x plus 3. Let's zoom in. Here they are. Negative 1.5 and negative 1. There's our 2 solutions, negative 1.5 and negative 1. So let's just find the one that has that. It's not this one. There's no negative 1. There's no negative 1. And here it is. So it's just written as a fraction. We know 3 halves is the same as negative 1.5. 3 halves is 1 1/2. The answer is C. So let's talk about another way we can look at quadratic functions. This is getting a little bit into Unit 3, but it's going to help us sort of wrap our brains around Unit 2 a little more. It says to write the quadratic equation from the graph. So we've talked about factors and solutions today, sort of the difference. So here, this picture, we can see the solutions, right? We can see that negative 4 is a solution and 6 is a solution. So if we know that these are the solutions, we can write the factors. It's just the opposite, x plus 4 and x minus 6. So remember, if we were to set these both equal to 0, it would take us right to the factors, or to the solutions. See, negative 4 and positive 6. So to find the factors, all you do is sort of work backwards. from the solutions. So they give us -4, the factor is +4. They give us a +6, the factor is -6. Let's try another one. Write the quadratic equation. Oh, sorry, one more step here. To write the quadratic equation, they would want you to multiply this out. So x times x is x squared. And then I go x times -6, -6x, 4 times x, and 4 times -6. And you get x squared minus 2x minus 24. So we went from the graph and the solutions to the polynomial. All right, let's do it again. Here we have the two solutions. X is 2 and x is 4. So we work backwards to the factors and we do the opposite sign. And then we multiply. X times x is x squared. -2 times x is -2x. X times -4 and -2 times -4. We'll combine like terms. You can see, do you see our mod chart sort of unfolding backwards? See, instead of now splitting the middle term, we're combining the middle terms. It's all working out. There's our polynomial. All right, so don't forget, as you're working in your OMHS, please make sure that you're going through the entire lesson. Take your time on assessments. If you need to take another attempt, make sure you're reviewing any missed questions before you're taking that second attempt on those quizzes. Take notes as you follow along. If you don't, if you print my notes for class, that's great. But also take notes on your own paper as you're going through the OMHS lessons, right? Practice problems down. You can review those notes to help you study before your test. All right, I'm also going to post some review resources in your OMHS in addition to this Playposit for your test tomorrow. Thanks, everyone. I'll see you in class soon.